Welcome to 18th lesson on nonlinear programming. Here we will discuss about the nonlinear programming equation solving by using a function called as quadprog in the MATLAB. In the MATLAB, the basic function here we are trying to give it as quadprog. The quadprog in general it will have the basic function like this in the MATLAB, like it will be go for 1 by 2 x and h is the Hessian matrix plus f of x, whichever the matrix it is going to be followed, and it is going to subjected to certain constraints which are given here. These are the constraints which are given here. It may be a maximization constraint or it may be a minimization constraint. Next we will go with the some simple example how we have to decode this Hessian matrix. So basically this Hessian matrix we will try to consider this one in terms of half of, like we will go for x1 square, x2 square and x3 square, and here it is x1 x2 and x1 x3. Here it will be x2 x1, that is second row second column, and here it is x2 x3. Here it will be x3 x1 and here it will be x3 x2. This is the Hessian matrix case. And how to decode this equation? For example, this is the minimization equation which we are having here. So this equation, how we have to decode it here? We will write the equation like this: h is equal to half. Since half is the case which will be there in the MATLAB by default, so I am considering half, and whatever the diagonal elements here we are having x square coefficients I will try to consider. So here the x square coefficient is 3 and x2 coefficient is 2 and x3 coefficient is 5. So what I will do is I will double this number here, that is multiplied by 2, because half should be there in the matrix. So I will take this number as 6, this number as 4 and this number as 10. Like 3 multiplied by 2 it is 6, 2 multiplied by 2 it is 4 and 5 multiplied by 2 it is 10. And whatever the matrices which we are having, in the remaining cases, for example let's just say as 4 we are having the 4 x1 x2 x1 x3 and x2 x1. So these matrices I will go for including here with the form of the same as it is, whatever the coefficient is there, the same coefficient I will do. Here I will get x1 x2. What is the coefficient for x1 x2? It is minus 4. I will write minus 4. And here it is x1 x3. What is the coefficient? It is minus 2. And here it is x2 x1. x2 x1 means x1 x2 both are same, it is minus 4. And here it is x2 x3, the coefficient is minus 2. And here it is x1 x3, that is x3 x1, that is minus 2. And here it is x3 x2, it is minus 2. So like this way I will write the Hessian matrix. Now again we have to write the A matrix, B matrix. A matrix, B matrix is common, as we are seeing from the constraints what we are having here in the constraints. Based upon the constraints, what we will do here, we will take the matrix in terms of it is a maximization constraint. I will go for minus 3, minus 5 and minus 2. And second matrix is 3, x2 is 0 and x3 is 5, and x1 x2 x1 greater than or equal to 0, x2 greater than or equal to 0, x3 greater than or equal to 0. So I will write like this: minus 1 0 0 0 minus 1 0 0 0 minus 1. So this will be my becoming my A matrix. and B matrix I will write here. B matrix is equal to, B matrix will be like here, it will be minus 10, 15, 0, 0, 0. So these are my inputs to the MATLAB. So the same inputs I will give into the MATLAB in the form of these commands. I will try to give into the MATLAB with the help of a function called as quadprog. Let me open the MATLAB software. Here I have to give the H matrix. H is equal to, what is the H value? 6 minus 4 minus 2 semicolon minus 4 4 and minus 2 semicolon minus 2 minus 2 10. This is my H matrix, followed by A matrix. A is equal to minus 3 minus 5 minus 2 semicolon 3 0 5 semicolon minus 1 0 0 0 minus 1 0 0 0 minus 1. So like that I will get a matrix. And what is the B matrix? I have to write here minus 10 semicolon 15, so it's minus 10, no, minus 10 semicolon 15 semicolon 0 semicolon 0 semicolon, like this. So simply what I will do is I will write the function case here as 0 0 0. Since why I am taking it as a 0 0 0 case, because if you observe this equation does not having any term which is of first order. Okay, like 4x1 x1 ax1 plus bx2, like that we don't have any order, so I am writing f as 0. Now I'll go for the function as f comma f min is equal to quadprog of, then I will get the syntax h comma f comma a comma b, close the brackets, and I will try to press the enter button. Then the execution is going to be takes place, and this is my x1 value and this is my x2 value and this is my x3 value. This is my functional minimum value which I have got from the MATLAB. So like this I have to calculate the quadprog, that is non-linear programming in the MATLAB. Thank you.